Welcome to www.happynumbers.org. Today's lesson is solving algebraic equations containing fractions. We've had a lot of practice in solving algebraic equations using addition and subtraction and multiplication and division and the inverse or the opposites of those. And now we're going to look at an equation that has a fraction in it. And this equation says 3/4 times x equals 9. And by the way, just as an aside, you may see it written like this sometimes, 3/4 x with x in the numerator, but this is the preferred way of writing it. This is the preferred way, 3/4 times x. Well, I think we remember when we were talking about just normal fractions, division of fractions, let's say, 2/3 divided by 1/2, we knew that we rewrote the problem, 2/3, we turned it into a multiplication problem, and we used the reciprocal of 1/2, which is 2/1. In other words, we turned the second fraction upside down and it became a multiplication problem. And so that's just normal division of fractions. Well, in this instance, in working with equations that have fraction component to it, our approach is exactly the same. We have to get the variable or the unknown alone by itself on one side of the equal sign and all the numbers on the other side. Well, the relationship between 3/4 and x is multiplication. This means 3/4 times x. We could have actually written it this way, like that, 3/4 times x. Well, if the relationship is multiplication, then we can use the opposite of multiplication or the inverse of multiplication, which is division. And we can divide this 3/4, we can divide it by 3/4. Well, if we're going to divide 3/4 by 3/4, we are really 3/4 times 4/3. So we're going to divide this by 3/4, but we're really multiplying by 4/3. Now, if we do that on this side, then we have to multiply this side by 4/3, because whatever we do on one side of an equation, we must do on the other. Well, if I multiply this side by 3/4 and 4/3, these all cancel out. So now I have x is equal to 9/1 times 4/3. And 3 can go into 3 one time, 3 goes into 9 3 times. And when I multiply, I have x equals 12/1, which is 12. Same exact thing. Okay, so we're saying then that x is equal to 12. We solved for 12. Well, let's go back to our initial problem. 3/4 times x. And let's substitute 12 for x. Well, 3/4 times 12/1 is equal to 9. We just substituted 12 for x. Well, let's do the multiplication. 4 goes into 4 one time. 4 goes into here 3 times. We have 3 times 3 is 9/1, or 9. So 9 equals 9. Therefore, our answer is correct. Let me just review this process again. Our approach is exactly the same. We want to get the x on one side of the equal sign and all the numbers on the other side. The relationship here is multiplication. So I can use the inverse operation or the opposite operation of multiplication, which is division. And if I'm going to divide 3/4 divided by 3/4, what I'm really doing is 3 fourths times the reciprocal of this, 4 thirds. So I'm really then multiplying this side by 4 thirds. And if I'm multiplying this side by 4 thirds, I have to do the same thing here. And then these cancel out, and then I solve for x. All right, let's take a look at another problem here. Let's take 2y, 2 thirds times y, and actually, let me write it the preferred way. 2 thirds times y is equal to 8. Well, we approach this in exactly the same fashion. We have to get the unknown, or the variable, y by itself on this side, and all the numbers on the other side. The relationship here is multiplication, so I can use the inverse or opposite operation, which is division. And if I'm going to divide 2 thirds by 2 thirds, I'm really multiplying 2 thirds times the reciprocal, which is 3 halves. And if I multiply this side by 3 halves, I have to multiply this side by 3 halves. Everything cancels out here, because 2 goes into 2 one time, 2 goes into 2 once, 3 goes into 3 one, 3 goes into 3 one. So then I wind up with y is equal to 8 times 3 halves, or 8 over 1. 2 will go once, 2 will go 4 times, and I multiply across. Y is equal to 12 over 1, which is 12. So the answer to this problem also is 12. Well, good. We'll take a look at one more here. Let's take negative 4/5 w is equal to 12. Oh, and by the way, let me, the preferred way of writing this, sometimes you may see it written like this, or sometimes you might see it written like this, but the preferred way is to have the negative like so. Okay, well, the process is exactly the same. We want to get w all by itself, and we want to get all the numbers on this side. Well, I have 4/5 times w, negative 4/5 times w. Well, then I know this is multiplication, and so I'm going to use the opposite, which is division. So I'm going to divide this by negative 4/5. But if I divide this by negative 4/5, I'll make that negative sign a little smaller. I'm really multiplying by negative 5 over 4. And if I do that here, then I have to do this here. And I have to multiply this by negative 5 over 4. Well, okay. Now, if everything will cancel out here. 5 will go into 5, 5 will go into 5. And since I'm multiplying a negative times a negative, it's a positive. So I have positive w equals, now 12 over 1 times negative 5 over 4. 4 will go this 1 times, 4 will go into this 3 times. 3 times negative 5 gives me negative 15. Okay? That you follow that process. This was multiplication, so I divided, which means I'm really multiplying by the reciprocal, and I had to multiply by negative 5 over 4. Okay? And the same thing here, negative 5 over 4. Good. Well, let me put up a problem or two for you. Let you work them. Let's try this one. 5n, my bad, 5/6n equals 10. Whoops, there goes the buzzer. Well, put your DVD on pause, work this problem, and turn it back on, and we'll go over it. Good. All right. We want to get n by itself, our variable or unknown. The relationship between 5/6 and n is multiplication, so I'm going to use the inverse. So I'm going to use division. I'm going to divide 5/6 by 5/6, which means I'm really multiplying by the reciprocal, 6 over 5. And if I do that on that side, then I have to do that on this side. All of this cancels out, and I have n is equal to 10 over 1 times 6 over 5. 5 goes 1 time, 5 goes 2 times, and I get 12. So n is 12. Excellent. Let's give you one more. I know we're going a little over here. 3/7 a equals 21. Go ahead and put your DVD on pause, work that out, and then we'll go over it. Let's see how we did. If we want to isolate a, we know this relationship is multiplication, so we're going to use the opposite or inverse, division. We're going to divide 3/7 by 3/7, which means we're really multiplying 3/7 by 7/3. And if we do that on that side, we have to do it on this side. 7 and 7, that cancels out. That cancels out. We wind up with a equals 21 over 1 times 7/3. 3 goes 1 time. 3 goes into 21 7 times. 7 times 7 is 49 over 1. So our answer is a equals 49. Excellent. Good. Well, sorry I went a little over. Thank you very much. See you next time.